more really cool rules and properties for working with exponents. So in 11.3, the I can statement is I can divide and simplify monomials using the quotient rule. So we're going to talk about the quotient rule for exponents. We've talked about negative exponents and 0 for an exponent, and multiplying exponents, multiplying monomials, and the power rule there. So let's talk about this warm-up problem right here. It says any number to the 0 power is 1. We talked about that yesterday. So we could represent that with this little picture right here. B to the 0 power is 1, and that's just representing any number to the 0 power is 1. A negative in the exponent means, make sure you've got this word, reciprocal. Okay, so what that means is we're going to flip from top to bottom or bottom to top, depending on where it is. So the negative means reciprocal, so this is going to be a b to the n on the bottom, and remember 1 is part of any multiplication or division problem, so we're going to put that up there. And then for the rest of these problems on the warm-up, it just says simplify, so we're going to be practicing some of the rules that we've already learned. So this is 7 to the 19th times, 7 to the 10th times 7 to the 19th. So we end up with 7 to the 29th. Should look familiar. Negative m to the 5th times negative 3m. Again, let's take care of the coefficients first. So that's going to be a 3. We've got 5 m's right here and one more right there. So that's to the 6th. And then we've got some strange expressions right here. Well, gosh, this is just a fraction. So let's see. I can cross cancel those. That's a 5 on the top and a 1 on the bottom. So that would just be 5. If I take a look at this one, I don't get quite as lucky here, but I can do this. 2 goes in here 3 times, and 2 goes in there 7 times. So that would be 7/3 with a little bit of cross cancellation. And then let's take a look here. Ooh, this looks like a nasty mess. 2 times 2 times 3 times 3 times 7, and 2 times 2 times 7. Well, this is all a multiplication problem, so I can actually cancel this. Like, really what I did here, this is 2 times 7 and this is 2 times 3. So really what I did is I just canceled the 2's, and then we're left with the 7/3. So let's go ahead and do that. I've got 2 2's here and 2 2's there. I've got a 7 here and a 7 there. So what I'm left with is a 3 times 3, or in other words, I'm left with a 9. Okay? All right, let's take a look at this one. Y to the negative 6. A negative in the exponent means reciprocal, so this is 1 over y to the 6th. Done there. Any number to the 0 power is a 1, so this is going to be a 7 on the top, because that's totally fine with a positive 1 for an exponent. Negative in the exponent means reciprocal, so that's going to be n to the 8th. And again, if these look familiar, these are probably from the assignment or from the notes that we've done. And this one right here, we'll run through and take a look here. Something that we notice right away, z to the 0 power, that is just a 1, so we don't even need to worry about that in the multiplication problem. The coefficients here are negative 3 and 2, so that's going to be a negative 6. The x has a negative exponent on it, so we're going to do the reciprocal of that, so that's going to be x to the 5th there. And the y has a negative exponent on it, so that's going to be y to the 8th there. And let's see, we've taken care of everything there, and that is the simplified version of that expression. Now, as a quick reminder, when we multiply expressions with the same base, got to have the same base, then we add the exponents. Okay, and that's called the product rule for exponents. So if we had b to the m times b to the n, it was b to the m plus n. We literally just add those together. Well, if that's true, I mean, stop and think about what we know about math. A lot of times we're just learning how to do something and undo it. Multiplication is related to division, addition is related to subtraction and stuff like that. So if this is true, if this rule with the products is true, what do you think we do when we divide expressions with the same base? Well, take a guess. If we add the exponents here, then what we do is we would subtract, and we do it in this order. We subtract the bottom exponent from the top exponent. So this is sometimes called the quotient rule for exponents, and it looks like this. Notice here we multiplied them together, so we took the first one and we added the second one. On this, we're going to take the first one and we're going to subtract the second one. So it's b to the m divided by b to the n is b to the m minus n. Now, it's really important that we recognize we usually only write answers with positive exponents. So we really like positive exponents. They have a way of just simplifying things and making things really easy. But you might keep in mind this, that when we do a subtraction problem, that may produce negative exponents. So if we use the quotient rule like this, there are going to be times where we end up with a negative exponent. And because of this, we might want to think of problems using only positive exponents and then cross-canceling cross-canceling the factors. And I'll show you how we work this. This means there's usually two main ways to simplify division problems involving exponents. We can just flat out apply the quotient rule for exponents, or we can use this idea of writing things with positive exponents and then cross-canceling factors and stuff. So I'm going to show you example number one, but I'm going to do it two different ways, and I'm going to show you why you might like the second way better. So technically, this is how we do it using the quotient rule. Same base here, same base here. So we're going to do 7 to the 3 minus the 5. So this is going to be 7 to the negative 2. The negative in the exponent means reciprocal, so we're going to write this as 1 over 7 squared. We're going to circle that and we're done. On this problem right here, we do have some coefficients, so let's go ahead and simplify those. So I'm going to cross cancel this. That would be a 5. So we would have 5, and then this would be x to the 10 minus 6. So this is 5x to the 4th, so we're done right there. And then on the next one, you'll notice a couple things about this. First of all, we've got a negative exponent. So first thing I'm going to do is I'm going to move that to the bottom. So I'm going to write x to the 5th there. I'm also going to take this one and I'm going to write y to the 2 minus 8, because those have the same base, so I'm going to subtract the bottom exponent from the top, take the first one and subtract the bottom one, if you want to say it that way. And so this is y to the negative 6 here and x to the 5th here. We've got a negative in the exponents, so what we're going to end up doing is we've already got the x to the 5th down there. The negative in the exponent means reciprocal, so I write the y to the 6th down there, and then again, 1 is part of any multiplication problem, so we're going to go ahead and write that. Now, I'm going to show you how to get the same answers in what I consider to be a little bit better technique. So I'm going to put a big check mark by this. I like this method better. I think it's better in the long run. So this is what I think. This means there are 3 7s on the top, and there are 5 7s on the bottom. So that means these 3 would cancel with 3 of those, and there would be 2 left on the bottom. So that means it's 7 squared on the bottom, none left on the top. So we're basically cross-canceling things. Now, if I were to write that out, here's what it would look like. 7 times 7 times 7, 7 times 7 times 7 times 7, okay? And we go through and we multiply. So I'm going to cancel these 3 7s with those 3 7s. So 3 canceled with 3 down here, and that means there's a 1 left on the top, and that means 7 squared on the bottom. So that's another way to do it. I'm going to do this again. Let's see, the 3 cancels with the 15, that makes a 5. There are 10 x's on the top and there are 6 on the bottom. So that means 6 of these cancel with 6 of these. That means there's 4 left. So there's a 5 left and 4 x's. So we'll just circle that. I find this to be much quicker, especially on problems like this. So take a look. This one is going to have x to the 5th on the bottom, because that had a negative exponent. And then I'm going to think I've got 2 y's on the top and I've got 8 of them on the bottom. 2 of these are going to cancel with 2 of those, and that would leave 6 on the bottom. So this would be y to the 6th on the bottom. And you'll notice that it definitely takes up less work. Without this extra explanation on this one, it definitely took up less work. This one, I think it takes up less work, but these are kind of nice when they work out with positive exponents. They don't save you as much time, but I still think that this is quicker. So I really like this method right here, and that's the way I'm going to do most of these problems. So here's what we're going to do. Let's do the last couple. So there's nothing that I can do with the 7, the 6. So we're going to go ahead and leave the 7 here, and we're going to leave the 6 right there. Then we're going to look at the exponential expressions, or we're going to look at the variables. There's 1 m on the top, and there are 4 m's on the bottom. So this 1 m cancels with one of those, and there are 3 left. So the ones that are left are on the bottom. So a couple of quick things. If there are coefficients and variables, we're going to simplify the coefficients first, like we did here. We got those figured out. Then simplify the variables and write them in alphabetical order. We're still going to be writing in alphabetical order, so alphabetical, okay? And make sure you write it using positive exponents, okay? We don't want any negative exponents here. The other thing that I wanted to mention is you can actually keep in mind 4 quick things in order to get these problems right, okay? And I'm going to write top, bottom, cancel, and then I'm going to write left. So this is what you can do. You can go through and you can say, all right, we've got to take care of the coefficients. There's no getting around that. Negative divided by a negative is a positive. The 9's totally fine. Now, as we go through and we start looking at what variables we're going to cancel, we're going to say this. How many m's on the top? There are 7. How many m's are there on the bottom? There are 17. How many of them cancel? So 7 of them cancel. If 7 of them cancel, then the question is how many are left? Well, if you had 17 and you canceled 7 of them, then you would have 10 left. So this is m to the 10th right there. And of course, there's nothing to cancel the n to the 3rd with, so we just circle that. So it's kind of a little quick 4-step thing where you can kind of walk yourself through this. So I'm going to do the same thing on this one. And we're going to take a look here. So we've got a -5 on the top and a 20 on the bottom. Well, the first thing that we're going to do is we're going to reduce that. We're going to say 5 goes in here once and 5 goes in there 4 times. So this is a negative on the top and we've got a 4 on the bottom. Now it's important to put that negative there because if everything disappears from the top, we want to make sure that we've got a -1 up there. That would get the answer wrong if we didn't have that there. The next thing I'm going to do is I'm going to move this stuff to the bottom. So I'm going to have an x to the 5th and an x to the 2nd. So when I move that down there, because it's got a negative exponent, I've got an x to the 5th and an x to the 2nd. Okay, so we'll keep track of that for the time being. Then I'm going to move my attention to the y's. And again, back to these questions. How many are on the top? 3. How many are on the bottom? 1. How many cancel? Well, 1 of them cancels. How many are left? 2. And where are they left? They're left on the top. So this is going to be y squared on the top. Let's take a look at the z's again. How many on the top? 1. How many on the bottom? 6. How many cancel? 1 of them cancels. And how many are left? There are 5 left in there on the bottom, so this would be z to the 5th. Now we're almost done with this. We're not quite finished. If we had been really quick and noticed, hey, wait a minute, those are both x's, so I've got 5 here and 2 here, we'd write -y squared, and then we'd have 4 x to the 7th, z to the 5th. We'd circle that and we'd be done. It's possible to go straight from here down to here and not miss a beat. So that's how you do that problem right there. Let's continue on, and I'm going to zoom in on this just a little bit, and we're going to keep in mind these ideas here. So let's go ahead and simplify here. Negative divided by negative is a positive. Okay, so I'm going to cancel those off. 10 goes in here once, 10 goes in here twice. So I've got a 2 here. Now notice I've got a positive, even though it's not written. I keep in mind that I need a 1. Maybe I'll put that back at the end. Okay, but I put a 2 in the denominator. Okay, how many a's on the top? 2. How many a's on the bottom? 2. How many cancel? These 2 will cancel with 2 of those. So how many are left? None of them are left. There are no a's at all. Now that would cancel to be a 1, and we may need a 1 in a second, but we'll hang on. Okay, how many b's on the top? There are 2. How many b's on the bottom? There are 1. How many cancel? 1 cancels from here and here, so that means there's 1 left, and it's left on the top. So this would be b to the 1st on the top. We'd circle that and we're done with the answer. That's it. Now, if we had written a 1 here because we knew it was positive, if we had written a 1 here because those cancel or something like that, totally okay. We'd still just want to write the answer as b over 2. So here's the awesome part about this. After this completely ugly mess, I mean, look at that. After looking at this and simplifying it, we just get b over 2. Much, much simpler than what we had there. Okay, let's move on and take a look at this one. We're going to simplify the 9 and the 15. We're going to reduce those coefficients. That's going to be a 3 and that's going to be a 5. So we've got a 3 on the top and a 5 on the bottom. And I kind of like it when this happens because automatically I know I've at least got something on the top and something on the bottom. Then we've got a q to the 4th and an r to the 6th. There are no other q's, so nothing to cancel with. So that would be q to the 4th. And there's an r to the 6th, nothing to cancel with. They've both got positive exponents, so we leave them where they are. That's kind of a cool problem. That one goes very quickly. And then here's the last one. Let's go ahead and take a look at this one. We've got an 11 and we've got a 55. So 11 goes in here once. 11 goes in here 5 times. Now, if we were going to write this, it's true we can write the negative, so negative fractions, we could write this. Negative a over b, we could write negative a over b, or we could write a over negative b. Any one of those is just fine. We do normally write it out front or on the top. I kind of like writing it on the top, so I'm going to go ahead and do that, and I'm going to put the 5 there. So we've got the positive divided by a negative taken care of. We've got 11 divided by 55 taken care of. We canceled them off, and we've got a 5. And then we're going to go through in here and take a look. There are no negative exponents, so this is good. How many x's on the top? 2. How many x's on the bottom? 4. How many cancel? 2. How many are left? 2, and they're on the bottom. So I'm going to write an x squared down here. Let's see. Let me cross that off and do that. Okay. How many y's on the top? 3. How many y's on the bottom? 5. How many cancel? 3 of them cancel, so there would be 2 left there. So that's going to be a y squared on the bottom. How many z's on the top? 4. How many z's on the bottom? 6. How many cancel? 4 of them cancel, so that means there's 2 left, and the 2 that are left are on the bottom, so I'm going to go ahead and write that on the bottom. And then I take a look at this and I realize, hey, wait a minute. Everything that's left is on the bottom. The only thing on the top is a negative, but don't forget, we've got to have that 1 in there. Okay, that's how to do the problems. I realize this is a lot to keep track of, but these are really important rules for working with exponents. So please make sure you practice, ask questions if you got them, and good luck on the assignment.